Hello everyone. Today we will continue with the concepts that we started yesterday. In fact, I will start by reminding you about the things we took yesterday, and then we will do two exercises together so as the concept becomes much clearer. What did we do yesterday? Yesterday, we learned about displacement of an object, velocity of an object, acceleration of an object. We started by saying if an object changes its position, then it is getting displaced. And displacement is nothing but final position minus initial condition. We refer to it as delta x, and it's x final minus x initial. Here it is. Okay? Unit of displacement is meter, centimeter, kilometer, just the proper unit of displacement. These are the proper units of the displacement. If we follow the metric system, then it is meter. Okay, but it doesn't always have to be meter. It can be kilometer, centimeter, decimeter. So this is about displacement, what we learned yesterday. What else we learned yesterday? We learned that someone can cover the same distance, but in different times. Here, when we talk about fast, slow, same speed, okay? So what we talked about, if something changes its speed over a particular distance, then we can calculate this speed by dividing the total distance by the total time. We refer to this as average speed. So average speed is total distance divided by total time. Velocity at a particular time is the displacement over delta t. Distance and displacement can be the same thing if an object is just moving in one dimension and it's not changing direction. For example, if the object is going from Saida to Sur, that is toward the south, and it doesn't go back, then the displacement and the distance are the same, because it's just going in one direction and it's not going back. So the distance and displacement are the same and are the same. But it's not always true. Yesterday we discussed cases when the distance and displacement are not the same. Go back to yesterday's lecture to see when this happens. When does it happen? Now, what are the units of speed? This is not a math course, so everything has a unit. Unit of V has to do with delta x over delta t. What's the unit of distance or displacement? It's meter. What's the unit of time? It's second or hour. So the unit of velocity is meter per second, kilometer per hour. Okay, so these are the ones that we mostly use. This is about velocity. And then we said, if an object changes its velocity, because it's very rare, for example, for someone to go from one place to another at exactly the same speed. Sometimes we speed up, like in this example. Sometimes we speed down, like in this example. So there is a change in speed, and that's when acceleration happens. So acceleration happens when there is a change in speed. Again, acceleration is delta V over delta T. And A average is V average over delta T. Now, acceleration can be positive or negative, just like velocity can be positive or negative, depending if we're going with the x direction or the minus x direction. Displacement can be positive or negative. Look at examples we mentioned yesterday. Also, acceleration can be positive or negative. If the car is speeding up, then acceleration is positive. If the car is speeding down, acceleration is negative. This is not always the case, and I'm going to talk about this more in future lectures. But for now, just imagine it like this. These are only true if we are moving along the positive x-axis. Okay? We're going to talk more about it in future lectures. Now, what are the unit of acceleration? Acceleration, if we look at it, it's v over t. So what is the unit of v? It's meter per second. Okay. And what are the units of t? It's second. So I have meter per second over second, which gives me meter per second squared. Meter per second over second is meter per second squared. It can also be kilometer per hour squared. These are the most units we use for acceleration. Okay, so this is just reminders from yesterday. And yesterday I solved 4 simple examples on these concepts. Today I will solve 2 more examples, also from your booklet. So we will start with a bus travels 280 kilometers south on a straight path with an average velocity of 88 kilometers per hour to the south. So the bus is moving to the south, the velocity is moving to the south. So the positive axis, we take it to be to the south, okay? So here I'm drawing the drawing. Okay, I'm drawing the drawing, but it's not really correct, but you understand what I mean. So here is the positive x-axis. Here is the positive x-axis. Okay. Now, so what's happening? So a bus travels 280 kilometers south. So the distance covered is 280 kilometers to the south. 280 kilometers to the south at a speed of 88 kilometers per hour. Okay. The bus stops for 24 minutes. After that, the bus stops for 24 minutes. Then it travels 210 kilometers at 75 kilometers per hour, also to the south. So this is here to the south. I actually put text to the south. Positive. This is to the south. Okay, since everything is to the south, I don't worry about that displacement and distance are not the same. It means they are the same, and velocity is positive to the south, so I don't have to worry about the sign of the velocity as well. Now, the first question, how long does the whole trip? So yesterday we did not deal with multi-section problems. Yesterday we dealt with one segment, and we said, for example, they give me the velocity, they give me the time, they say calculate the distance. Here it's a 3 segments journey. So you imagine this as the following. A van, minivan coming from Sur to Saida, then it stops in Saida to collect more passengers, then it goes from Saida to Beirut. Okay, so you imagine the scenario like this. And here I like to call it as section A, section B, section C. So as I like to call it section A, section B, section C. So how long does the total trip last? The total trip lasts whatever section A takes plus section B plus section C. So I have to get delta T for A. How long does segment A takes? Plus how long does segment B takes? Plus how long does segment C takes? Okay. Let's start. So total time, it's delta TA plus delta TB plus delta TC. Now, how much is delta TA? Delta TA, do I know how to calculate it? Yes. Here, I have the distance and I have the velocity. Can I get the time? I have to remind myself that V average equal total distance here. So V average equal distance over time. So I just have to remind myself of this. Now I have the distance, so V average, so that's what I'm using here. V average is delta X over delta T. Since we have section A, section B, section C, I decided to call delta V average A, delta XA, delta TA. Okay. Now we just plug the values that we are given. V average A is 88, delta XA is 280 over delta TA. Here I don't have to worry about units because everything is in kilometer and hours, okay? Except for this in minutes, so we have to change this. So I just follow the math here and I will find that delta TA is 3.18 hours. Now, how much is delta TB? Delta TB is given. It's simply 24 minutes. I don't have to calculate anything here. The only thing I have to pay attention to that it's in minutes. Everything else is given in hours. So I have to change to hour. And how do we change minutes to hour? We took this yesterday. We just divide by 60. So delta TB is 0.4 hours. Then how much is delta TC? Delta TC, we also have the average and distance. So we use exactly what we use to calculate delta TA. So we start with the average equal delta XC over delta TC. I plug the given numbers and I get that the time is 2.8 hours for TC. Then to get total time, I have to add 3.18 plus 0.4 plus 2.8, and this gives me total time equals 6.38 hours. Okay, so this is how long does the total trip last. Then what is the average velocity for the total trip? What's the average velocity for the total trip? I also have to remember the formula, V average equal total distance over total time. Now, what is the total distance? Total distance is the distance by A plus the distance by B plus the distance by C. The distance by A is 280 kilometers. It's given over here. The distance by C is 0 because it stopped for 24 minutes. Then the distance by C is 210 kilometers. So you add them up. Then you divide by total time, which we have just calculated. Total time we have just calculated over here. So it goes over here. and we get the average to be 76.8 kilometer per hour. Okay, so such problem, it's called several section problems, and these are very common in exams. Let's do another problem and include acceleration. Try to include acceleration. So number 7, page 2. Suppose a treadmill has an average acceleration of 4.7 times 10 power minus 3 meter per second. So this is given acceleration. How much does its speed change after 5 minutes? What is this 5 minutes? What is this 5 minutes? This 5 minutes is the total time of the time you spent on the treadmill. So we have the acceleration and we have the delta time, but it's in minutes. So what do I need to do? I need to multiply by 60 in order to get it in seconds. So we're converting from minutes to seconds. Here we multiply because minute is 60 seconds. We multiply. Now, what does it mean if the treadmill's how much does its speed change? What is this speed change? What is he asking me to calculate? He's asking me to calculate speed change. So, and this is nothing but delta V. I want to tell you, these are just English tricks, and these things don't appear in an exam. Okay, so in an exam, we make it clear that you need to calculate delta V. We will not be saying how much does its speed change. So speed change is nothing but delta V. I'm sorry. Speed change. It's delta V. So he wants me to calculate delta V. So he gives me A, he gives me T, and he asks me to calculate delta V. What do I use? It's a simple formula. Acceleration equal delta V over delta T. So delta V, which is asking me to calculate, will be A delta T. Here I do cross multiplication. A is 4.7 times 10 power minus 3. Delta T is 300. I calculate delta V. So within 5 minutes, the speed of the treadmill changes by 1.41 meter per second. This is what part A talks about. Now, if the treadmill's initial speed is 1.7 meter per second. So what is he giving me here? He is giving me the initial. And he's asking for final speed. So he wants the final. Okay, what do I use? I use the definition that delta V is V final minus V initial. So delta V is 1.41. V final, this is what I want to get. V initial is 1.7. V final equal, I take 1 minus 1.7 to the other side. It becomes plus 1.7 equal V final. So V final is 3.11 meter per second. Okay. So today we will have our second live session. I will be talking more about this. I will be taking questions regarding these past 2 lectures. Talk to you soon. Bye-bye.